Hey everyone, welcome back to Singularity. I'm so pumped you're here today because we're about to dive into something totally mind-bending. Imagine a world made entirely of antimatter, the weird, flipped version of the stuff we're all made of. It's like stepping into a sci-fi movie, right? But here's the big question. What happens when this antimatter world crashes into our regular matter universe? Get ready, because we're about to explore some cosmic collisions that'll blow your mind. From Earth getting slammed by an antimatter asteroid to black holes duking it out, we're in for a wild ride. So let's jump right in. First up, picture Earth, our cozy little planet just chilling in space. Out of nowhere comes Apophis, that infamous asteroid we've all heard about, except in this crazy twist, it's made of antimatter. And when antimatter meets matter, kaboom! They annihilate each other, turning into pure energy, no scraps left behind. It's the ultimate cosmic fireworks show. So, this antimatter Apophis, 370 meters wide, about the size of a football stadium, slams into Earth. The instant it hits our atmosphere, the annihilation kicks off. Antimatter particles meet matter particles, and they vanish in a burst of energy, following Einstein's ELMC2. Apophis weighs about 27 million tons, so if it wipes out an equal amount of Earth's matter, that's 54 million tons converting to energy. How big is that bang? Let's compare it to the Hiroshima bomb, which was 15 kilotons of TNT. This collision, it's like 1.3 trillion Hiroshima bombs, 1.3 million of them, all at once. What's that mean for Earth? Well, it's not looking good. The blast would vaporize everything, land, seas, the air itself. Gamma rays and heat would scorch the surface, and the shockwave would tear the planet apart. Earth wouldn't just be wrecked, it'd stop being a planet, turning into a cloud of gas and radiation floating through space. An antimatter Apophis would be the end of us, and it'd be one heck of a show. Now, let's zoom out to the sun, our life-giving star, crashing into an antimatter sun. Both are the same size. When they collide, all that mass turns into energy. That's around 10 to the 47 joules, which is bonkers huge. For context, a supernova, when a massive star explodes, releases about 10 to the 44 joules. This matter-antimatter sun smash? It's 1,000 times more powerful than a supernova, 1,000 times the boom. The result? A dazzling explosion of gamma rays and light outshining the galaxy for a split second. The energy would rip through the solar system, obliterating Mercury, Venus, Earth, Mars, everything. Even Jupiter and Saturn couldn't hide from the blast. The radiation and shockwave would erase our solar system entirely, leaving just a fading glow behind. It's like a supernova on overdrive, an annihilation that resets our cosmic neighborhood in the most dramatic way possible. Okay, let's kick it up a notch. Imagine a neutron star, those super dense stellar corpses, except this one's made of antimatter, colliding with a regular matter neutron star. Neutron stars are wild already, tiny, about 20 kilometers across, but insanely heavy. In this case, let's say each one's got 3 times the sun's mass. When they smash together, their combined mass turns into energy, giving us about 1.1 times 10 to the 48 joules. That's even more intense than the sun collision, packed into a space smaller than a city. How strong is that? It's not quite a quasar, those are black holes chowing down on material, beaming out 10 to the 40 watts over eons. This is a one-off blast, but for a moment it'd outshine a quasar big time. The explosion would hurl gamma rays and particles across space, deadly for hundreds of light years. Any planets or stars in that zone? Toast. The whole galaxy would see it, a blinding flash brighter than anything ever recorded. It wouldn't wipe out the galaxy, but it'd carve out a danger zone hundreds of light years wide, a cosmic warning sign everyone could spot. Insane, right? Now for the big finish, an antimatter black hole versus a matter black hole. Say each has 10 times the sun's mass, one formed from matter, the other from antimatter. As they spiral closer, their accretion disks, those swirling rings of stuff around them, start mixing. Matter and antimatter in the disks annihilate, spitting out gamma rays like crazy. It's a galactic light show, a prelude to the main event. But here's the twist. You'd think when they merge, all that matter-antimatter combo would unleash a galaxy-shaking explosion. Nope. Black holes don't care about matter or antimatter. Once stuff crosses the event horizon, it's just mass, no distinctions. So, their merger? It's like any other black hole collision. They blend into one bigger black hole, sending out gravitational waves, space-time ripples we've detected with tech like LIGO. The energy's still massive. Some mass turns into those waves, but it's not the annihilation fest you'd expect. The real action's in the disks beforehand, not the merger itself. The universe loves throwing curveballs like that, doesn't it? So there you go, an antimatter world crashing into our matter reality, from Earth's fiery end to black hole surprises. It's wild to imagine, huh? What do you think? Got any questions or ideas for our next cosmic deep dive? Toss them in the comments. I'd love to hear from you. If you had fun on this antimatter adventure, please hit that subscribe button and smack that like. It means the world to Singularity. Thanks for hanging out with me today, and I'll see you in the next one. Keep your eyes on the stars, and I'll catch you soon. Bye!